Hello everyone, and welcome to our presentation on the Windows Server 2016-7740 study guide, specifically focusing on the pyramid reconstruction method. Today, we'll start with Chapter 1, which covers installation and configuration. In this opening slide, I want to give you a quick overview of what's ahead. We'll discuss how to lay a solid foundation for your servers by choosing the right edition, deploying them properly, and ensuring they're activated and patched for production. Think of this as the concrete slab of your data center pyramid. If you get this part wrong, everything above it can wobble. We'll explore different installation options, including the additions like Desktop Experience with its GUI, Server Core with its minimal footprint, and Nano Server, which is ultralight and optimized for cloud environments and containers. You'll learn the scenarios where each edition fits best, whether it's for regular servers, cloud-optimized workloads, or Hyper-V hosts. So, let's dive in and start building that solid foundation for your Windows Server 2016 environment. All right, let's take a look at Server Core, which is ideal for data center deployments that require a strong focus on security and performance. It's a minimal installation option, which means fewer components running, reducing the attack surface and improving overall efficiency. On the other hand, the GUI version is better suited when administrators need local management capabilities or app compatibility. It's more user-friendly, but comes with a larger footprint. When it comes to upgrading, there are three main paths: a clean install, an upgrade, or migration. I usually recommend a clean install because it tends to have fewer legacy issues and a cleaner system overall. Upgrades, meanwhile, are in place and only supported from Windows Server 2012 or 2012 R2, and only if you're staying within the same edition and architecture. Migration involves moving roles and data to new hardware or virtual machines, which is often the better choice when crossing server versions. Now let's discuss the servicing models. Nano Server uses the current branch for business, or CBB, which is more agile and suited for rapid deployment and updates. In contrast, the core and GUI versions follow the long-term servicing branch, or LTSB, providing stability over a longer period, ideal for environments where reliability is critical. Moving on to deployment tools, DISM is a powerful utility for managing Windows images. You can add or remove features with commands like DISM, Online Enable Feature, Mount or Unmount WIM or VHD images, and offline add drivers or packages. Then there's Windows System Image Manager, or WSIM, which helps build unattended answer files, crucial for automated deployments. PowerShell also plays a key role here. With commands like Install Windows Feature, you can install roles and features efficiently, and with Get Windows Feature, you can check what's available on your system. Finally, the Map Toolkit is a handy resource for capacity planning and readiness assessment, ensuring your environment is prepared for deployment or upgrades. All of these tools and options tie back to our overall goal: deploying secure, reliable, and efficient Windows server environments tailored to different needs and scenarios. Let's take a closer look at activation models. First, we have KMS, or Key Management Service, which is a centralized activation method that requires at least 25 client activations before it can activate systems. It's great for managing large environments. Then there's MAK, or Multiple Activation Key, which allows for a one-time online activation for each server, suitable for smaller setups or individual servers. AVMA, or Automatic VM Activation, is quite convenient because virtual machines automatically activate when they're running on a properly licensed data center host. No manual intervention needed. Lastly, Volume Activation Services is a broader solution that helps manage activation at scale across many devices. Now, moving on to other core topics. When it comes to boot modes, UEFI versus BIOS, it's important to note that Secure Boot is only supported with UEFI. This is a key security feature that helps prevent unauthorized firmware and software from loading during startup. Regarding drivers and hotfixes, these need to be injected into images beforehand, especially for bare metal installs, to ensure the system runs smoothly right out of the box. And for manual patching, we use the Windows Update Standalone Installer, known as MSU files. They're useful when you need to apply updates manually. Let's also clarify what's outside the scope when we define by exclusion. This slide doesn't cover Active Directory forest or domain design, which is something we'll explore in detail in 7742. It also doesn't include advanced networking services like DNS, DHCP, or VPN, covered in 7741. And we're not discussing SCCM or Intune cloud deployment here. Instead, we focus on WSUS and basic servicing. Now, to help visualize some of these concepts, think of Nano Server as stripping down a car to just the engine and wheels. It's incredibly fast and lightweight, but you lose some of the comfort features. Server Core is like buying a bare-bones laptop. No bloatware, which means faster boot times, but you'll manage it mostly remotely. Both options give you streamlined, efficient servers tailored to specific needs, fitting into our overall theme of optimizing and managing your infrastructure effectively. Let's talk about the GUI first. Imagine it like a laptop with a big touchscreen. It's very user-friendly and easy to operate, but it also tends to be heavier and more resource-intensive. So, while the GUI makes management straightforward, it comes with a trade-off in terms of performance and size. Now, onto KMS versus AVMA. Think of KMS as an office manager who unlocks all the doors. You need someone actively managing each door individually. On the other hand, AVMA is like doors unlocking automatically if the building has the right master key. It's more streamlined and automatic, reducing manual effort. Next, we have a critical thinking scenario. If you deploy Nano Server, which has no GUI at all, how do you handle management? This question pushes us to consider remote management tools, scripting, or PowerShell. Since there's no GUI, automation becomes essential. Moving on, why is Server Core often the default recommendation for data centers? Because it minimizes the attack surface, reduces the need for patching, and consumes fewer resources, making it more secure and efficient for large-scale deployments. Now, when would an in-place upgrade be justified over a migration? Generally, if your environment is stable and you want to preserve configurations with minimal hassle, an in-place upgrade can save time. But if you need a fresh start or to move to a different hardware, migration might be better. What happens if your KMS server goes down? Well, clients won't be able to activate automatically, which can cause compliance and licensing issues. You need to plan for redundancy or alternative activation methods. And why is secure boot critical in modern data centers? It helps ensure that only trusted, signed firmware and software run during startup, enhancing security. But it might block some legitimate custom or older hardware drivers, so you need to be cautious. Now moving to practice drills, recall level questions. First, which Windows Server edition supports local logon? The answer is all editions, but specifics depend on configuration. True or false? You can upgrade directly from Windows Server 2008 to 2016. The answer is false. You need to upgrade in stages or perform fresh installs. Which DISM command mounts a WIM file? It's the mountimage command, which prepares offline images for servicing. Which activation model is best for a host running many VMs? The key management service, since it simplifies activation across multiple virtual machines. And what's the default installation type for Windows Server 2016? It's Server Core, emphasizing minimal footprint and security. Now, applying this knowledge, if your data center has 300 servers and dozens of VMs, which activation model is best? KMS, because it scales well and reduces management overhead. You need minimal patching and headless deployment for container hosts. What edition? Windows Server Core, for its security and lightweight footprint. A remote branch office with only 1 or 2 servers. What activation type works best? MAK, because it's simple and suitable for small environments. To add drivers to an offline image, which tool should you use? DISM, as it's designed for servicing offline images efficiently. And for reducing attack surface with Hyper-V, would you choose GUI or Core? Core, since it minimizes the attack vectors and reduces unnecessary components. Throughout all this, remember that choosing the right tools and configurations aligns with your overall goal of building a secure, manageable, and efficient data center. All right, let's dive into the flip the classroom drill, which I like to call the capstone stone. Imagine you're the professor for a moment. Windows Server comes in 3 main flavors: GUI, Core, and Nano. Now, Nano is the lightest of the 3, but it has a major limitation. It doesn't support local logon. That means you can't directly log into a Nano server like you would with a GUI or even Core. Server Core, on the other hand, is minimalistic and designed for security. It strips away everything unnecessary, which reduces the attack surface and makes it easier to manage securely. It's a great choice for environments where security is a top priority. Then we have the GUI version, which is the most user-friendly because it offers the graphical interface most people are familiar with. But of course, that comes with increased resource consumption and a larger attack surface. Now, here's the critical question I want you to think about. If you were designing a secure cloud data center, which of these options would you pick? And more importantly, how would you manage that server remotely without a GUI? The key point here is understanding the balance between security, manageability, and resource efficiency. For a secure cloud environment, you'd likely favor Server Core or Nano because they're more secure by default. Managing them remotely becomes essential, using PowerShell, remote management tools, or other command line interfaces, since you won't have the graphical interface to click around. This ties back to our overall theme of building secure, efficient, and manageable infrastructures. The choice depends on your specific needs and how you plan to handle remote management, emphasizing the importance of automation and remote tools in modern server management. Let's dive into Chapter 2, which focuses on storage solutions. Think of storage as the backbone of any data center. It's what keeps everything running smoothly behind the scenes. Windows Server 2016 introduces some powerful new features to enhance storage capabilities. These include RayFS, Storage Spaces Direct, Deduplication, Storage Replica, and flexible virtual disk support like VHD and VHDX. All of these tools are designed to improve resiliency, boost performance, and increase efficiency across disks, clusters, and even remote sites. You can think of storage as the circulatory system of your data center pyramid. Everything depends on data flowing securely, smoothly, and reliably. Now, let's look at the core concepts you need to be exam-ready. Starting with file systems, NTFS, or New Technology File System, is a mature and reliable system that supports features like compression, EFS encryption, quotas, and access control lists. It also supports deduplication, which helps save space by removing duplicate data. Next up is RayFS, or Resilient File System. RayFS offers better resilience against corruption thanks to features like integrity streams and auto-healing. It's optimized for virtualization workloads, making it ideal for modern data center environments. However, RayFS does have some limitations. It doesn't support deduplication, at least before Windows Server 2016, and it can't be used for boot volumes. Plus, it has fewer legacy features compared to NTFS. Moving on to Storage Spaces and Storage Spaces Direct, or STD Storage Spaces pools physical disks into a single virtual pool, simplifying management and increasing flexibility. This pooling allows you to create resilient, scalable storage solutions that adapt to your needs. Throughout this chapter, remember that these storage options are vital for building a reliable, high-performing data center infrastructure. They form the foundation that supports all your compute and application workloads. Let's take a closer look at the different storage layouts available. We have the simple layout, which is straightforward but lacks resiliency, meaning it doesn't protect against disk failures. Then there's the mirror layout, which can be configured as 2-way or 3-way, providing redundancy by copying data across disks. Lastly, the parity layout offers a balance between storage efficiency and fault tolerance. Moving on, support for thin provisioning is available. This feature allows us to allocate storage space dynamically, which helps optimize utilization by only using the space actually needed. Now, let's explore Storage Spaces Direct, which was introduced in 2016. This technology enables us to pool local disks from each server across a cluster, effectively eliminating the need for a traditional shared SAN. It's versatile, working seamlessly with NVMe, SSD, and HDD drives, and it even supports auto-tiering to optimize performance automatically. Plus, it integrates with scale-out file servers, known as SOFS, to enhance scalability and availability. Next, let's discuss data deduplication. Its main purpose is to save space by removing duplicate file data, which is particularly useful for scenarios like virtual desktop infrastructure, VDI, file shares, and backup targets. However, it's not recommended for databases or Exchange servers, as deduplication can impact performance or data integrity in those cases. To monitor deduplication status, you can use commands like getDedup status and getDedup volume. When enabling deduplication on a volume, you simply run enable dedup volume. Keep in mind, rehydrating deduped data can affect backups, so you need to plan accordingly. Finally, let's look at Storage Replica, or SR. This feature supports both synchronous and asynchronous replication. Synchronous replication commits data to both sites simultaneously, making it ideal for low-latency LAN environments where zero data loss is critical. On the other hand, asynchronous replication acknowledges writes locally and then copies the data later, which is better suited for disaster recovery over WAN links, though it carries a small risk of data loss. These partnerships are typically configured between volumes or servers to ensure data consistency across locations. Connecting all these features together helps us build resilient, efficient, and scalable storage solutions, which is the core theme of today's presentation. Now, let's talk about testing. We use the test failover CMDlet to validate our disaster recovery plans, ensuring everything works smoothly when it truly matters. Moving on to disk management and virtual disks, it's essential to understand the differences between partitions, GPT versus MBR. GPT is more modern and supports larger disks, while MBR is older but still in use. When it comes to volumes, we have various types: simple, spanned, striped, mirrored, and RAID 5. Each serves different needs, whether for performance, redundancy, or capacity. Speaking of virtual disks, there's VHD and VHDX. VHD is the legacy format, supporting up to 2 terabytes, but VHDX is the newer standard, supporting up to 64 terabytes and offering better resilience against corruption. Checkpoints are another important feature. They let us save the state of a VM disk at a specific moment, which is crucial for testing or quick recovery. We have CMDlets like New VHD, Resize VHD, and Mount VHD to manage these virtual disks efficiently. Let's clarify what we focus on here. We define storage concepts by exclusion, meaning we're focusing on Windows Server built-in features rather than vendor-specific SAN solutions like EMC or NetApp. Our goal isn't to dive into advanced Azure storage solutions or deep hardware RAID controllers, but to understand OS-level storage management. Now, think of storage spaces as if you had multiple USB drives fused into one large drive, plus safety nets like mirroring or parity, so if one drive fails, your data stays safe. Comparing file systems, NTFS is like a trusty old truck, reliable and flexible, while RAIFS is more like a modern electric car, optimized for performance and auto-repair, though it has fewer features. Finally, Storage Replica is about creating a real-time copy of your data across locations. Imagine 2 safes in different cities. Synchronous replication is like putting the money in both safes at the same time, slower but safer. Asynchronous is more like stashing the money in one safe first, then copying it over later, which is faster but carries a bit more risk. Now, let's consider why you might choose to deploy RAIFS in a Hyper-V cluster instead of NTFS. RAIFS offers resilience against data corruption, which is critical in a virtualized environment where uptime is essential. It also supports larger volumes and more advanced data integrity features, making it a solid choice for high availability setups. However, it's important to weigh these benefits against any compatibility considerations. Next, think about the risks involved with asynchronous replication over a WAN. While it's faster and less resource-intensive, it does carry the risk of data loss if a failure occurs before the data is fully replicated. This trade-off between speed and data safety is key to understanding your recovery objectives. Now, let's talk about deduplication and backup software. Deduplication reduces storage needs by eliminating duplicate data blocks, which can significantly save space. But it's crucial to know how this interacts with backup processes. Sometimes, deduplication can complicate restores or affect backup performance if not configured properly. Moving on, why might storage spaces direct eliminate SAN costs? Because it leverages direct attached storage to create a shared pool without needing expensive SAN hardware. But this approach can introduce trade-offs like increased management complexity or potential performance concerns depending on your hardware choices. Finally, when would you choose VHD over VHDX? If you're working with older systems or need compatibility with legacy tools, VHD might still be necessary. But VHDX is generally preferred for larger disks, supporting up to 64 terabytes, and offers better performance and resilience features. Now on to the test questions. True or false? RayFS supports boot partitions. The answer is false. RayFS is designed primarily for data storage, not system boot volumes. To enable deduplication on a volume, you use the specific PowerShell CMDLET, which is Enable Dedup Volume. And for large VHD formats, VHDX is the format that supports up to 64 terabytes. Regarding storage spaces layouts, there are three main configurations: simple, mirror, and parity. And if we're talking about replication modes, the one that guarantees zero data loss is synchronous replication, because it confirms data is written to both locations simultaneously. Now, applying these concepts practically. If you need to save space for 500 VDI desktops, deduplication is your best feature. For a cluster with only local disks but needing shared storage, storage spaces direct is the ideal tech. When replicating over a 200-mile WAN, asynchronous replication is usually preferred to reduce latency, even though it risks some data loss. For workloads requiring quotas and file compression, RayFS offers better features than NTFS. And finally, to grow a VHDX, you'd use the Resize VHD PowerShell CMDLET to expand its capacity efficiently. That covers our key points. Thinking critically about these technologies helps us make smarter, more reliable infrastructure decisions. All right, let's imagine we're teaching this concept together. Storage spaces direct is like pooling local disks across multiple servers into one large, fault-tolerant storage system. Think of it as combining many small refrigerators into one big, smart walk-in cooler that keeps everything safe. Now, if one of those refrigerators' compressors fails, the system has resiliency built in, meaning it can handle that failure without losing data or access. The system redistributes the load, and the remaining compressors keep everything running smoothly. But here, the key point, if multiple compressors fail at the same time, that's when resiliency is truly tested. It could lead to performance issues or even data loss, depending on how the system is configured. This example helps us understand the importance of fault tolerance and how redundancy is vital in maintaining continuous operation. It ties back to our overall theme of designing resilient, high-availability storage solutions. Let's dive into Chapter 3, which focuses on Hyper-V virtualization. To start, think of Hyper-V as Microsoft's hypervisor that allows multiple virtual machines, or VMs, to share the same physical hardware while remaining isolated and secure. Back in 2016, Hyper-V received some significant upgrades. Things like nested virtualization, which lets you run a VM inside another VM, shielded VMs for enhanced security, rolling cluster upgrades for better availability, production checkpoints for reliable backups, and improved virtual networking features. Imagine Hyper-V as an apartment building, your data center, where the building itself is the host, and each apartment is a VM. Each unit is secure and independent, but they all share the same structure. Now let's talk about VM configuration, which is core to understanding how Hyper-V works. First, there are different generations of VMs. Generation 1 supports legacy BIOS and is compatible with older operating systems, using IDE controllers. Generation 2, on the other hand, uses UEFI firmware, supports secure boot, larger virtual disks, and can even boot via PXE with synthetic network adapters. Next is dynamic memory. This feature allows you to allocate startup RAM, set minimum and maximum memory limits, and enable ballooning, which dynamically adjusts memory based on demand. It's a smart way to optimize resource use and overcommit host memory across multiple VMs. Then there's smart paging. Think of it as a temporary disk space used during VM startup if your physical RAM isn't enough. It helps ensure the VM can start smoothly even when resources are tight. Resource metering is another important aspect. It tracks CPU, RAM, disk, and network usage for each VM. This helps you monitor performance, manage capacity, and plan for scaling. Moving on, checkpoints, often called snapshots, are a way to save the state of a VM at a specific point in time. They're invaluable for testing, backups, or before making major changes because they allow you to revert back if needed. So in summary, these features, generation types, dynamic memory, smart paging, resource metering, and checkpoints, are all key building blocks. They help you efficiently configure, monitor, and manage your VMs, ensuring a secure and flexible virtual environment. Let's start by talking about checkpoints. Standard checkpoints are primarily used to save memory and device state, which is useful for quick recovery or testing. However, it's important to remember that they are not application consistent, so they might not capture the full state of an application. On the other hand, production checkpoints are more robust because they utilize VSS inside the guest operating system. This means they create application-consistent snapshots, which are much better for production environments, and they avoid crash states. To manage these checkpoints, we have specific CMDlets like Checkpoint VM and GetVM Snapshot, which help create and manage snapshots efficiently. Moving on to virtual networking, we have different types of virtual switches. External switches connect your virtual machines to the physical network, enabling communication outside the host. Internal switches connect only the host and the VMs, creating an isolated environment within the host. Private switches are even more restricted, allowing communication only between VMs, which is useful for certain testing scenarios. NIC teaming is another key concept. By combining multiple network interface cards, we enhance redundancy and increase bandwidth. There's also a newer feature called Switch Embedded Teaming, or SET, introduced in Windows Server 2016. It serves as a built-in alternative to traditional NIC teaming, specifically for Hyper-V, simplifying network management. Another important technology is SRIOV, or Single Root I/O Virtualization. It allows direct assignment of a NIC to a VM, bypassing the virtual switch altogether, which significantly improves network performance. Now let's look at migration technologies. Live migration is a game changer because it allows us to move a running VM with no downtime, perfect for maintaining service availability. However, it does require a cluster or trusted hosts to work effectively. Quick migration involves saving the VM's state, moving it, and then restoring it, which results in a small downtime, suitable for less critical scenarios. Shared nothing migration is quite flexible. It's used to move VMs between standalone hosts over the network, without shared storage. Storage migration is another powerful feature. It lets us move virtual hard disks to another disk or storage system while the VM continues to run, minimizing disruption. Finally, the cluster rolling upgrade feature enables us to upgrade a Windows Server cluster from 2012 R2 to 2016 without any downtime, ensuring continuous service during the upgrade process. All these technologies and features work together to provide a robust, flexible, and high-availability virtualization environment, supporting our overall goal of efficient and reliable infrastructure management. Now, let's take a closer look at the security features available in Hyper-V. One of the key components is shielded VMs, which are designed to protect your virtual machines from potentially compromised host administrators. To enable this, you need to have the Host Guardian service in place. Shielded VMs utilize encrypted disks, secure boot, and TPM integration to ensure the integrity and confidentiality of your VMs. Additionally, there's enhanced session mode, which improves the user experience by redirecting local devices and the clipboard into the VM, making management more seamless. Another important feature is guarded fabric, which provides a secure host infrastructure specifically for shielded VMs, adding an extra layer of protection at the network and host level. Moving on to the new features introduced in the 2016 version, we see options like hot add and remove for network interface cards and memory, allowing for more flexible resource management without shutting down the VM. Production checkpoints are now set as the default, which are more reliable for creating consistent backups. Nested virtualization is also supported, meaning you can run Hyper-V inside a VM, which is great for testing and development environments. Lastly, host resource protection helps to prevent performance issues caused by noisy neighbors, by throttling resource usage from VMs that are consuming excessive resources. It's important to understand these features within the context of the overall Hyper-V architecture, focusing on on-premises environments rather than cloud-based IaaS platforms like VMware or Azure, unless we're discussing migration scenarios or hybrid setups. Keeping these distinctions clear helps us better leverage the security and management capabilities of Hyper-V. Imagine live migration as if you're moving a full Netflix stream from one TV to another without any buffering. That's the seamless experience we aim for. When we talk about quick migration, think of pausing your game, switching consoles, and then resuming. There's some downtime, but the process is much faster and requires less configuration. Shielded VMs are like putting your valuables into a safe that even the landlord or the admin can't access, adding an extra layer of security to protect sensitive data. Dynamic memory is similar to giving each student a flexible water bottle that can fill up more or less depending on their needs, all from the same cooler. This allows for efficient resource allocation based on demand. Now, let's consider some critical thinking questions. Why would we deploy production checkpoints instead of standard ones? Well, production checkpoints are application-aware, meaning they capture a more complete state, which is crucial for accurate recovery in a live environment. But with quick migration, especially in financial workloads, there's a risk of data inconsistency or incomplete transactions, so we need to be cautious. When comparing SET with NIC teaming, SET reduces dependencies because it's a software-based solution that doesn't rely on multiple physical NICs, making it more flexible and easier to manage. Shielded VMs, while highly secure, can also be operationally limiting because they restrict certain management tasks, which might impact troubleshooting or live migration options. Nested virtualization comes into play when we want to run a VM inside another VM, useful for testing, training, or isolated development environments without needing extra physical hardware. Moving on to some quick recall questions. Which VM generation supports UEFI and Secure Boot? That's generation 2. True or false? Standard checkpoints are application consistent. That's false. They're typically not. To create a checkpoint, you use the save VM name command. SRIOV provides direct access to network hardware, greatly improving network performance by reducing latency. And finally, which switch type isolates VM to VM communication only? That would be a private switch. So these concepts tie back into our overall theme of optimizing performance, security, and flexibility in our virtualization environment. Now, let's talk about applying the right checkpoint type for your SQL Server VM. To ensure guaranteed consistent backups, you need to use a transaction log checkpoint. This type makes sure that the backup captures a precise point in time, which is critical for restoring your database without data loss. Next, when upgrading a 2012 R2 cluster to 2016 with zero downtime, what feature makes that possible? It's the live migration. This feature allows you to move virtual machines between hosts without any interruption to service, keeping your applications running seamlessly. For migrating between two standalone hosts over Ethernet, which method works best? That would be storage migration. It enables you to move VMs and their storage across hosts over the network without shutting down the VM, making it ideal for live environments. Now, let's consider how shielded VMs impact disaster recovery scenarios. Shielded VMs offer enhanced security by encrypting the VM disks and protecting against unauthorized access. This means that in disaster recovery, even if the storage or host is compromised, the VM's data remains secure, simplifying compliance and recovery planning. Finally, if you want to track a VM's exact resource consumption, which feature should you use? That's resource metering. It provides detailed metrics on CPU, memory, disk, and network usage, helping you monitor and optimize your VM environments effectively. And as a quick exercise, think of live migration like moving tenants between apartments without disturbing their dinner. Now, what happens if bandwidth drops during that move? The migration could slow down or even pause, risking interruption. To prevent that, you want to design your network with sufficient bandwidth and perhaps implement quality of service policies to prioritize migration traffic, ensuring a smooth, uninterrupted move. Welcome to Chapter 4, where we dive into containers. Let's start with an overview. Containers in Windows Server 2016 are like lightweight, isolated environments for running applications. They share the same operating system kernel, which makes deployment faster and more consistent compared to traditional virtual machines. There are two main types to know about: Windows Server containers, which share the kernel, and Hyper-V containers, which provide an extra layer of isolation. Think of containers as the food prep stations in a busy commercial kitchen. Everyone uses the same ingredients, meaning the OS kernel, but each station has its own tools and workspace. Now, let's look at the core content, which is really what you need to be exam-ready. First, Windows Server containers share the host OS kernel. They're lightweight and start quickly. The isolation here is namespace-based, which means each container operates in its own isolated environment, but still shares the core OS resources. On the other hand, Hyper-V containers run each container inside a lightweight virtual machine. This provides stronger isolation, which is especially useful when running untrusted workloads or needing additional security. Next, let's touch on Docker integration, which is essential for managing containers efficiently. The Docker engine, or daemon, runs on the host machine and is responsible for managing your containers. You also have Docker Hub and Azure Container Registry, which act as central repositories for pulling and pushing container images. These tools make it easier to develop, share, and deploy containers across different environments. So, in summary, understanding these container types and how Docker integrates with them helps us build more flexible and secure application environments. Now, let's take a closer look at how we use immutable templates to spin up containers. These templates serve as the base images, so whenever we need a new container, we start from a consistent, predefined state. Moving on to some key commands, first up is Docker build. This command allows us to create an image from a Docker file, which is essentially a blueprint for our container. Once we have our image, we can use Docker run to start a container based on that image. To see what's currently running, we use Docker PS, which lists all active containers. If we need to save any changes we've made inside a container, we use Docker commit to create a new image that reflects those updates. Sharing images is straightforward with Docker push and Docker pull, allowing us to upload and download images from registries. And if a container is no longer needed, Docker RM will remove it from the system. Now, let's talk about container networking. There are a few different approaches here. NAT, or Network Address Translation, uses the host IP with port mapping, which is simple and effective for many scenarios. Transparent networking assigns containers' IP addresses on the physical network, making them appear as separate machines. Overlay networks are designed for multi-host container setups, allowing containers on different hosts to communicate seamlessly across a shared network. Lastly, Docker Network Create enables us to define custom networks, grouping containers together for more advanced configurations. Shifting gears to management tools, PowerShell is a powerful option. Commands like install Windows feature containers and new container help set up and manage containers on Windows. The Docker CLI remains our main tool for day-to-day operations, offering a straightforward way to control containers and images. And for those who prefer a graphical interface, Windows Admin Center provides a GUI that integrates container management, especially in newer Windows builds. By understanding these commands, networking options, and management tools, we're better equipped to efficiently deploy, manage, and troubleshoot containers in our environments. Let's clarify the differences in container types. Windows Server containers are like roommates sharing the same apartment. They have separate bedrooms, which are their isolated processes, but share the same kitchen and bathroom, meaning they share the same kernel. This makes them lightweight and efficient, but also means they depend on the host kernel's security and stability. Hyper-V containers, on the other hand, are like separate studio apartments in the same building. They are fully isolated from each other because they run inside a lightweight virtual machine built on the same physical host. This provides stronger isolation, which can be important for security-critical applications. Now, think of Docker images as recipes. Once you create a recipe, you can make as many identical meals or containers as you want. It's a way to standardize and quickly deploy consistent environments. In terms of scope, remember we're focusing on infrastructure deployment and the basics of container runtimes. We're not covering orchestration tools like Docker Swarm or Kubernetes, which are beyond our current exam scope. Nor are we diving into cloud-native CI/CD pipelines, just the essentials of container runtime basics. Now, some critical questions to consider. When would you choose Hyper-V containers over Windows Server containers? Typically, for scenarios that require stronger security or isolation, Hyper-V containers are the better choice. What risks do you face if a Windows Server container is compromised? Because they share the kernel with the host, a security breach could potentially affect other containers or the host itself, making isolation less robust. How do you decide between NAT and transparent networking? NAT is good for isolating containers and providing network address translation, while transparent networking allows containers to appear directly on the network, which is useful for certain communication needs. What happens if you make too many changes to containers without properly managing images? You risk creating a cluttered environment with inconsistent states, making it hard to reproduce or roll back. Proper image management is key to maintaining a stable deployment. Finally, how does containerization impact patching strategies compared to virtual machines? Containers can be patched more quickly since you update the images and redeploy, without needing to reboot the entire host, unlike VMs, which often require more extensive maintenance windows. And just a quick recall, true or false, Windows Server containers have their own kernel. The answer is false. They share the host's kernel, which is a key aspect to remember when assessing their security and isolation characteristics. Let's explore some key concepts here. First, which container type provides stronger isolation? Well, Hyper-V containers offer greater isolation because they run each container inside a lightweight virtual machine, providing a more secure boundary. In contrast, Windows Server containers share the host OS kernel, making them faster but less isolated. Next, if you want to see which containers are currently running, you can use a specific Docker command. It's quite straightforward. Just type docker ps, and it lists all active containers along with their IDs, images, and statuses. Now, for mapping container ports to the host, which container network type do you think is used? The answer is the NAT network type. It allows containers to have their ports mapped to the host, enabling communication between the container and the outside network. Moving on, if you need to install the containers feature using PowerShell, there's a specific CMDlet for that. It's Install Windows feature containers, and it enables container functionality on your Windows server. Let's think about application scenarios. When you need to isolate untrusted workloads on a multi-tenant host, which container type should you choose? Hyper-V containers are ideal here because they provide stronger isolation, ensuring that untrusted workloads don't compromise the host or other containers. If your goal is for containers to get real IPs on the corporate LAN, which network type would you select? That would be the transparent network type, as it connects containers directly to the physical network, giving them their own IP addresses on the LAN. Suppose you want to save the current state of a container as a new image. Which command do you use? The answer is Docker commit, which captures the current container's state into a new image. Now, if your developers need faster startup times compared to VMs, which container type should you recommend? Windows Server containers are the best fit here because they start up quickly, leveraging shared OS resources. Finally, let's consider the impact of committing too many changes to a single container. Over time, this can lead to a bloated and less manageable image, making it harder to maintain and potentially affecting performance. And for our Flip the Classroom drill, imagine you're teaching someone about containers, how they enable instant, consistent app deployment because they all use the same image template. Windows Server containers are quick but share the kernel, while Hyper-V containers are slower but offer enhanced security. Now, if you were running a financial service that requires strict isolation, which container type would you choose? I would opt for Hyper-V containers because they provide that extra layer of safety, ensuring sensitive data stays protected within its own virtualized environment. All right, let's dive into Chapter 5, which focuses on high availability and clustering. First, let's talk about the big picture. High availability, or HA, is all about making sure that your critical workloads stay online, even if something goes wrong with hardware or software. Windows Server 2016 has introduced some great enhancements in this area, like improved failover clustering, cluster OS rolling upgrades, cluster-aware updating, integration with storage spaces direct, and multiple Quorum models. Think of clustering as your emergency backup crew. If one team member drops out, another jumps right in without missing a beat. That's the kind of seamless continuity we're aiming for. Now, moving to the core concepts. Failover clustering basics. Essentially, a cluster is a group of servers, or nodes, working together to boost availability. This setup supports workloads such as file servers, Hyper-V virtual machines, scale-out file servers, and SQL Server databases. A key component here is cluster shared volumes, or CSVs. These are shared NTFS or RAIFS volumes accessible by all nodes in the cluster, allowing for flexible and high-performance storage management. Creating a cluster is straightforward with PowerShell, using the command new cluster, specifying the name and the nodes you want to include. Now, let's discuss Quorum models, which are essential for cluster health and decision-making. The node majority model assigns one vote per node, and it requires more than half of the nodes to be online for the cluster to function. The node and disk majority model adds a shared disk as an additional vote, providing more stability. Similarly, the node and file share majority uses a file share witness as a tiebreaker, which is especially useful in geographically dispersed clusters. There's also the legacy no majority, or disk-only model, but it's generally not recommended anymore due to its limitations. Finally, a new option introduced in Windows Server 2016 is the Cloud Witness, using an Azure blob as a witness, which is great for cloud-integrated environments and adds extra resilience. So, in summary, clustering and high availability are vital for ensuring your workloads stay online, and understanding these models helps you design resilient, reliable systems. Let's take a closer look at cluster-aware updating, or CAU. This feature automates the patching process for clustered nodes, and the key benefit here is that it minimizes downtime. How does it work? It systematically drains each node, applies updates, reboots if necessary, and then brings the node back online, all in a sequential manner. This approach ensures the cluster remains available throughout the update process. The management of CAU is streamlined with specific CMDlets like invoke cow run and get cow report, making it easier to control and monitor updates. Now, moving on to Cluster OS rolling upgrade. This feature allows us to upgrade cluster nodes from Windows Server 2012 R2 to 2016, one at a time, without disrupting the entire cluster. During this transition, we can support mixed mode operation, meaning both the old and new versions can run simultaneously, although this support is temporary. Ultimately, this process provides a zero downtime migration path, which is crucial for maintaining service continuity. Next, let's discuss Scale-Out File Server, or SOFS. This setup provides continuously available file shares, making it ideal for workloads like Hyper-V and SQL Server. It's optimized for high availability and performance, especially under demanding workloads. The magic lies in using SMB3, which offers features like transparent failover, multi-channel support, and encryption, ensuring data is both highly available and secure. Finally, we have storage spaces direct in clusters. This technology pools local disks across multiple nodes, effectively eliminating the need for traditional SAN infrastructure. It offers auto-resiliency and tiering capabilities across SSDs and HDDs, optimizing performance and redundancy. Plus, it's integrated with SOFS, providing a comprehensive solution for VM storage that is both flexible and scalable. All these features work together to create a highly resilient, efficient, and modern storage and update environment, core to our overall strategy of building robust and agile data centers. Let's talk about monitoring and failover policies. First, we have health monitoring of nodes and roles, which ensures that each component is functioning properly. If an issue is detected, failover thresholds come into play. For example, the number of failures before a role is moved to another node. We can also configure preferred owners and failback policies to control how roles are reassigned after a failure. It's important to note that these policies are defined by exclusion, meaning we set boundaries within which failover occurs, such as pyramid boundaries. This setup is different from Azure's global load balancing solutions like Traffic Manager or Front Door, which distribute traffic across regions. We're also not talking about app-level clustering, like SQL Always On, which is covered elsewhere, nor third-party SAN clustering hardware. Now, to help visualize these concepts, let me teach it in simpler terms. Think of a failover cluster as a relay race team. If one runner stumbles, another immediately takes the baton without missing a beat. Quorum is like a board vote. Majority agreement is needed for the cluster to keep functioning, ensuring decisions are made collectively and reliably. Clusterware updating is akin to rotating pit stops in Formula One. While one car pulls in for maintenance, the others keep racing, so there's no downtime. And a scale-out file server is like multiple checkout lines at a store, all serving the same inventory efficiently. Finally, let's consider why Quorum is so critical. Quorum prevents the cluster from splitting into isolated parts, which can lead to what's called a split-brain scenario. In such cases, each part might think it's the only active one, potentially causing data corruption or conflicts. Maintaining Quorum ensures that the cluster operates as a unified, consistent entity. Let's start by considering when you would choose a cloud witness instead of a file share witness. The cloud witness is particularly useful when you want a simple, reliable, and off-site voting mechanism that doesn't depend on your local infrastructure. It's ideal for geographically dispersed environments or when managing multiple sites, as it provides a neutral vote that helps keep your cluster online even if local resources are unavailable. Next, what's the advantage of cluster OS rolling upgrades versus migration? Rolling upgrades allow you to update the operating system of your cluster nodes without taking the entire cluster offline. This means minimal downtime and continuous availability, especially beneficial in production environments. Migration, on the other hand, often involves moving workloads and can be more disruptive, so rolling upgrades offer a smoother, more seamless upgrade path. Now, how does Storage Spaces Direct, or SOFS, improve Hyper-V resiliency compared to a normal file server? SOFS is designed for high availability and performance, providing shared storage directly connected to cluster nodes. It ensures that VM storage remains accessible even if a node fails, because data is replicated across multiple disks and nodes. This significantly enhances resiliency compared to traditional file servers, which might not be optimized for such rapid failover scenarios. What about the trade-offs in letting clusterware updating, or CAU, auto-patch versus manual patch scheduling? Auto-patching via CAU automates the process, reducing human error and ensuring patches are applied promptly, which improves security and stability. However, it offers less control. Sometimes patches can cause unexpected issues. Manual scheduling gives you more control over when patches are applied, allowing testing beforehand, but it requires more effort and oversight. Now, moving to the practice drills, let's recall some key commands and concepts. The command to create a new cluster is new cluster. The Quorum model that uses Azure as a witness is called the Cloud Witness, which leverages Azure storage for quorum voting. True or false? CSV volumes can be formatted with RayFS. That's true. CSVs can indeed be formatted with RayFS to optimize for data integrity and performance. The protocol powering SOFS's continuous availability is SMB3, which provides seamless, transparent failover for file shares. And which feature automates patching nodes with minimal downtime? That would be cluster-aware updating, or CAU. Now let's look at apply-level questions. If you need a quorum solution for a 2-node branch office cluster, which witness should you choose? The answer is a cloud witness, as it provides an off-site, neutral vote to prevent split-brain scenarios. During an OS upgrade where the cluster must stay online, the feature used is the rolling upgrade, enabling you to upgrade nodes without disrupting cluster services. For Hyper-V workloads that require transparent failover of VM storage, you'd configure the cluster's shared volumes role. If you have a node repeatedly failing workloads, tuning the failover policies, such as failover thresholds and delays, can help stabilize the environment. And for SAN-free high-availability storage across cluster nodes, the feature to consider is Storage Spaces Direct, or SOFS, which provides shared storage without needing SAN hardware. Finally, let's do the flip the classroom drill. Imagine explaining this. Failover clusters keep workloads alive by shifting roles to healthy nodes. The quorum is like the cluster's voting system, deciding if the cluster can keep running. Now, in a 2-node cluster without a witness, if one node goes down, the remaining node might assume the other is down too, risking a split-brain scenario where both think they are the primary. To prevent this, adding a witness, like a cloud witness, gives the cluster a tiebreaker, ensuring it only stays online when there's a clear majority. Designing it differently with a witness ensures higher availability and prevents split-brain failures. In this chapter, we're focusing on the maintenance, backup, and monitoring aspects that are essential for keeping our data center running smoothly over time. Remember, simply installing and configuring servers isn't enough. Ongoing management is crucial. Windows Server 2016 offers a range of built-in tools to help us with this. For example, it provides backup solutions, update management, anti-malware, and performance monitoring features. These tools act like the maintenance crew for our data center, ensuring everything stays operational, fixing issues before they become serious, and supporting long-term reliability. Let's start with Windows Server Backup, or WSB. To set it up, you simply install it using the command install Windows feature Windows Server Backup. It's capable of full server backups, backing up the system's state, and even bare metal recovery. You can schedule backups, which is key for regular maintenance. Using the command line, you'd start a backup with wbadmin start backup. To back up just the system state, it's wbadmin start system state backup. And if you want to see what backup versions you have, you use wbadmin get versions. Keep in mind, WSB doesn't support tape backups or advanced scheduling natively, so you might want to use Task Scheduler for that. Moving on to patch management, Windows Server Update Services, or WSUS, is your central hub for approving and deploying patches and updates. It allows you to control exactly which updates are installed and when, making sure your servers stay secure and up to date without surprises. Overall, these tools form the core of your maintenance strategy, helping you manage your servers proactively and efficiently, ensuring your data center remains secure and reliable over the long haul. Now, let's look at group targeting, which allows us to assign updates to specific server groups, making patch management more efficient. We can use CMDlets like get wsus update and approve wsus update to manage and approve updates through PowerShell. For manual patching, the Windows Update Standalone Installer, or MSU files, come in handy. When it comes to failover clusters, Cluster-Aware Updating, or CAU, provides automated patching to minimize downtime and keep everything running smoothly. Moving on to anti-malware and security maintenance, Windows Defender is our built-in antivirus and anti-malware solution. It offers real-time protection, along with regular signature updates to stay ahead of threats. Management can be handled via PowerShell with commands like get-mp computer status and update-mp signature. Plus, it integrates seamlessly with group policies, SCCM, or WSUS, giving us flexible management options. Now on to monitoring tools, which are critical for maintaining system health. Performance Monitor, or perfmon, lets us add counters for CPU, memory, disk, and network usage, and we can set up data collector sets for ongoing, long-term monitoring. It also allows us to set alerts based on specific thresholds, so we're notified of potential issues early. Resource Monitor provides real-time, detailed insights into CPU, disk, network, and memory activity, helping us diagnose problems quickly. Task Manager offers a quick live view of system performance, while Event Viewer logs detailed information for troubleshooting. Lastly, the Reliability Monitor provides a graphical overview of system stability over time, helping us identify patterns and recurring issues. All these tools connect back to our overall goal, maintaining a secure, stable, and well-managed environment for our systems. Let's start with workload monitoring. One of the key tools here is resource metering in Hyper-V, which allows us to track usage on a per virtual machine basis. So, for each VM, you can see how much CPU, RAM, disk, and network resources it's consuming. This helps us understand the workload distribution and identify any bottlenecks. When we look at performance counters, there are some common examples to keep in mind. For processor performance, we watch the percent processor time. That tells us how busy the CPU is. For memory, we look at the available MB to see how much free RAM we have left. Disk performance can be gauged by AVG. Disk sec read, which measures how long read requests are taking. And for network, bytes total sec gives us the total data being transmitted per second. Now, it's important to define what we monitor and what we exclude. Think of it as setting pyramid boundaries. This means we focus on core, essential monitoring and exclude things that are outside of our scope. For example, we're not talking about enterprise-scale SCCM patch deployments here, which are beyond the scope of this exam. Nor do we include third-party backup solutions, since we're focusing on Windows-native tools. And application-specific monitoring tools like SQL Profiler are also outside our core focus. Let's put some of these tools into perspective with simple analogies. Windows Server Backup is like having save slots in a video game. You can roll back to a safe point if something goes wrong. WSUS, on the other hand, is like a vending machine for patches. Centralized, controlled, so everyone pulls updates from a trusted source rather than direct from the internet. perfmon is like a car dashboard with custom gauges. You pick which metrics are most important to you. And Defender is like a guard dog that's always patrolling, constantly watching, but it still needs updates and training to be effective. So these tools and concepts help us maintain control, visibility, and security across our environment, fitting into the bigger picture of effective system management. Let's discuss some critical thinking questions to help you understand the importance of various backup and monitoring strategies. First, why is system state backup critical for Active Directory servers? Well, Because Active Directory is the backbone of your network's identity and permissions. If it's lost or corrupted, restoring the entire directory can be complex and time-consuming, so having a reliable system state backup ensures you can recover quickly and minimize downtime. Next, what risks come from approving all patches automatically in WSUS? While automatic approval saves time, it can introduce vulnerabilities if patches haven't been thoroughly tested. Sometimes updates can cause compatibility issues or even break functionalities, so blindly approving all patches can lead to unexpected problems. Then, how do you distinguish between a one-time CPU spike and a long-term bottleneck? A quick spike might be caused by a temporary process or workload, but a sustained high CPU usage indicates a deeper issue, perhaps inefficient applications or resource contention. Monitoring over time helps you identify whether it's a transient event or a persistent problem needing attention. What's the downside of relying only on Defender in enterprise environments? While Defender provides good baseline protection, it might not be enough for larger organizations. It can miss advanced threats or zero-day exploits, so relying solely on it leaves your environment vulnerable without additional security layers. And why might CAU be risky in a poorly tested patch cycle? Because if patches haven't been properly tested, applying them through cluster-aware updating can cause cluster failures or service outages. Without thorough testing, you risk introducing instability into your critical systems. Now moving to some practice drills. To start a system state backup, what command do you use? That's right, wbadmin start system state backup is the command. Which WSUS feature allows you to target updates to specific server groups? That's the target groups feature, enabling you to choose which servers receive particular updates, helping you manage your environment more precisely. True or false? Windows Server Backup supports tape drives. That's true. It can back up to tape drives, which is useful for off-site storage and long-term archival. For monitoring memory availability, which perfmon counter should you look at? The available MBytes counter shows you how much free memory is available, giving you a quick view of your system's memory health. And what's the PowerShell command to update Defender signatures? You'd run update MP signature to ensure your antivirus definitions are current and your system is protected against the latest threats. Applying this knowledge, if your domain controller fails, which backup type allows you to recover the entire forest or domain? That's a system state backup, which contains the essential information needed for such recovery. If you notice a web server showing high CPU usage at 3 a.m., which monitoring tool is best suited to investigate? Perfmon is ideal because it provides detailed performance data over time, helping you pinpoint the cause. For patch management across a cluster with zero downtime, what feature should you leverage? Cluster-aware updating, or CAU, allows you to update nodes sequentially without taking the entire cluster offline. And if your Hyper-V VMs need per-tenant billing reports, which feature helps? The resource metering feature provides detailed usage data, enabling accurate billing based on resource consumption. Lastly, if an admin disables Defender's real-time protection, what risks are involved? The system becomes more vulnerable to malware and zero-day threats, increasing the chance of infection and data compromise. Thanks for engaging with these questions. They're designed to reinforce your understanding of the critical tools and strategies that keep your environment secure and reliable. Now, my question is, if your WSUS server went offline for a month, how would you ensure your servers stay patched without breaking your patch management process? This is a crucial point to consider because, as we've discussed, a reliable patching strategy depends on consistent updates. If your WSUS server isn't available, you need alternative methods to keep your systems secure and up-to-date. One approach could be configuring your servers to use alternative sources or fallback options, like Windows Update Directly during the outage. Another important aspect is planning for such scenarios, maybe implementing a tiered patching process or having a secondary server ready to step in. Ultimately, the goal is to ensure that your patch management remains resilient, even if a key component like WSUS is temporarily unavailable. This connects back to our overall theme of building a robust, flexible patching strategy that minimizes risks and maintains security integrity.